pair of straight lines. Now we are going to see few concepts and few formulae in pair of straight lines. The first and the most important one is combine the equation of the pair of straight lines. To calculate the combined equation, we have to multiply the given equations. It's just very simple and very important. So, for the combined equations, we have to multiply the two given equations and should equal to 0. This is the combined equation. Okay. So, and now the general equation of pair of straight lines are ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Without knowing the general form, you couldn't perform any calculation. So, learn it properly. Okay. Angle between the pair of straight lines passing through the origin. That's the angle. Theta is the angle and it is tan inverse of 2 into h square minus ab divided by a plus b modulus value. Okay. So, while equating the general equation, okay, if you compare the general equation and the equation which is given in the problem, you can find the coefficients of the constants, you can find the values of the constants a, h, b, g, f and c. These are all some constant values. So, if you compare this general equation with the equation given in the problem, la kuduthirukra equation kuda, the general equation ni compare பண்ணும்போது, you can get the values for these constants. With these values, you can substitute the values of h, a, b, okay, so a and b. So, after finding the values h, a and b, you can calculate the value of theta. So, okay. If theta is the angle between the pair of straight lines, then theta is equal to tan inverse of 2 into modulus 2 into h square minus ab divided by a plus b. If the straight lines are parallel, h square is equal to ab is the condition. If the straight lines are perpendicular, then a plus b is equal to 0. What is a? A is the coefficient of x square and b is the coefficient of y square. If the sum of a and b is equal to 0, we can tell the straight lines are perpendicular. The condition for general second degree equation to represents the pair of straight lines. To check whether the given equation represents the pair of straight lines, this is the condition ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. As we know, the determinant form is very easy for us to calculate. AHG, HBG, HBF and GFC is equal to 0. If this value, the determinant value of this coefficient is equal to 0, then we can tell the given equation is represent the pair of straight lines. Okay, ஒரு equation கொடுத்து இது pair of straight lines represent பண்ணுதான்னு சொல்லி கேட்டாங்கன்னா இந்த determinant value equal to 0 ன்னு கண்டுபிடிச்சோம்னா yes, we can tell that the equation, given equation is representing the pair of straight lines. First question in exercise 3.3, if the equation ax square plus 5xy minus 6y square plus 12x plus 5y plus c is equal to 0 represent a pair of straight lines, find a and c. We have to find the value of the constants a and c. So, this is the given equation. What is the general form for the pair of straight lines? Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is the general form. While comparing these two equations, here we get the constant a is equal to a itself and 2h is equal to 5. Coefficients, equating the coefficients. Okay, 2hxy, that is 5xy. 2h is equal to 5. B is equal to minus 6. 2g equal to 12. 2f is equal to 5 and c is equal to c itself. Okay, this is what we get while comparing these two. So, with this you can find h is equal to 5 by 2 Similarly, G is equal to 12 by 2 and it is equal to 6. F is equal to 5 by 2. Now we have to find the constants A and B. What is the condition given here? This equation represents a pair of straight lines. Not only pair of straight lines, pair of perpendicular straight lines. It's given like that in the book. Okay. So pair of perpendicular straight lines. If the pair of straight lines to be perpendicular, the condition is, so the condition for the lines, the pair of straight lines are perpendicular is A plus B equal to 0. So, the sum of A plus B is 0, A and B is 0. So, here A is A and B is minus 6. So, A plus minus 6 is equal to 0. That implies A is equal to 6. Okay. With this we have found our constant A. Now, we have to find C. So, these lines are, the two lines are pair of straight lines. So, what is the condition for the given equation is represent a pair of straight line. Condition for the given equation represent a pair of straight lines. The determinant form of value of AHG, HBF and GFC is equal to 0. If it is equal to 0, then we can tell, if the determinant value of this is equal to 0, we can tell that the given equation represent a pair of straight lines. Okay, so we have to find the value of C. So, I am going to substitute the constants here. So, A instead of H 5 by 2, instead of A we can substitute 6, right? We have found. So, 6, H is 5 by 2. What about G? G is 6. Again H is 5 by 2. B is minus 6. F is 5 by 2. G, similarly G is 6. F is 5 by 2. And C is C. We have to find. This is equal to 0. Now we have to expand. We have to expand this. To make the determinant calculation, more simpler, I am going to use one rule, that is R1 is simplies R1 minus R3. If one row or particular column has more zeros, it will be easy for us to find. You can expand directly also, or else you can do like this, R1 minus R3. So, I am going to subtract R1 and R3. So, R1 minus R1 represents R1 minus R3. So, 6 minus 6, it is 0. 5 by 2 minus 5 by 2, it is also 0. That is 6 and C. So, this will become 6 minus C. The second row is 5 by 2 minus 6 and 5 by 2. And the third row is 6, 5 by 2 and C is equal to 0. Shall we expand now? So, if I take 0 and if I multiply this 2, I will get 0. So, 0 into anything we multiply with 0, you will get 0 only. So, while multiplying it with this 0, you will get 0. Again minus, while multiplying with this 0 also, you get only 0. And now it is 6 minus C. The coefficient, third coefficient is 6 minus C. So, leaving this row and this column, you get 5 by 2 into 5 by 2, 5 by 2 into 5 by 2 minus 6 into minus 6, it is minus 36. It is equal to 0. Okay. So that implies 6 minus c into 25 by 4 plus 36 is equal to 0. So c into this number, here it is a here we have some value 25 by 4 plus 36, and here we have an expression 6 minus c. So either 6 minus c must be equal to 0 or this expression must be equal to 0. But this expression, it is a number, while simplifying this you will get some value. Okay, so that doesn't equal to 0. So we can tell 6 minus c is equal to 0. Okay, after simplifying this, while cross multiplying you will get 0 only. So 25 by 4 plus 36 must not be equal to 0. So 6 minus c should be equal to 0. This implies 6 is equal to c. That is, c is equal to 6. Now we have found the two constants, two values, a and c. A is also equal to 6 and c is also equal to 6. Show that the pair of straight lines 4x square plus 12xy plus 9y square minus 6x minus 9y plus 2 is equal to 0 represents two parallel straight lines, and also find separate equations of straight lines. So first we have to show that this equation represents the pair of straight lines, two parallel lines, and also we have to find separate equations. So the given equation is here. What is the general form? Ax square plus 2hxy plus by square plus 2gh plus 2fy plus c is equal to 0. Without knowing the general form, we couldn't solve the formula. So while comparing these two equations, I get a is equal to 4 and 2h is equal to 12. That implies h is equal to 6. B is equal to 9. Okay, what is the condition for the given equation represents the pair of straight lines? So the given condition to prove the equations represent a pair of parallel straight lines. The given condition is h square minus ab is equal to 0. Okay, so what is h? It is 6 square. We have to check. So h square minus ab is equal to 6 square minus 4 into 9. 36 minus 36, and it is equal to 0. So h square minus ab is equal to 0. That implies the given equation represents pair of parallel straight lines. The formula, parallel straight lines. Okay, so now we have to find the separate equations. We have to find the separate equations. So from the given equation, okay, 4x square plus 12xy plus 9y square, I am going to take the first three coefficients, coefficient of x square and xy and y square, this equation. Okay, so 4x square plus 12xy plus 9y square, I take this equation. So we will consider this, that is equal to, okay, we have to factorize this, 4x square plus 12xy plus 9y square, we have to factorize this. So 4 9s are 36. In center, the sum should be 12, right? So we can take 6 and 6. So 4x square plus 6xy plus 6xy plus 9y square. We are considering this expression alone. Okay, so while taking common 2x as common, get 2x plus 3y. Similarly, here we can take 3y as common. So if we take 3y as common, it is again 2x plus 3y. So 2x plus 3y into 2x plus 3y, that is equal to 2x plus 3y the whole square. While factorizing this, we get 2x plus 3y the whole square. Okay, so I am going to represent the given equation. What is the given equation? This one, 4x square plus 12xy plus 9y square minus 6x minus 9y plus 2 is equal to 0. I am going to rewrite this equation with this factor. Okay, so 4x square plus 12xy plus 9y square minus 6x minus 9y plus 2 is equal to 0, and it becomes for this three terms I can write 2x plus 3y the whole square, isn't it? This is the factors of this expression. Okay, so I am replacing this 4x square plus 12xy plus 9y square with this expression, this one. Okay, the factorize பண்ணா இதுதான் கிடைக்குது. அதனால இந்த டேர்முக்கு பதிலா நான் இதை எழுதியிருக்கேன். ஓகே, அதே மாதிரி 2x plus 3y வச்சு இதையும் எழுதணும். ஓகே, ஸோ 2x plus 3y. To write this term, okay, 6x minus 9y minus 6x minus 9y in terms of 2x plus 3y. For that, if I take minus 3 as common from these two terms, this term will become minus 3 into 2x plus 3y. இதே 2x plus 3y வச்சு எழுதுறோம். Okay, so minus 3, if I multiply minus 3 with 2x, I'll get minus 6x. Minus 3 with 3y, I'll get minus 9y. Plus 2 is equal to 0. இதை வச்சு எழுதியாச்சு quadratic equations. Okay, a pair of parallel straight lines represent பண்ணா factors இந்த மாதிரி தான் வரும். Okay, parallel இல்ல ordinary lines, pair of straight lines னு கொடுத்திருந்தாங்கன்னா factors separate equationsக்கு factors different-ஆ வரும். Okay, so substitute two x plus 3y is equal to some constant z in the given equation, in the above equation, and it becomes z square minus 3z plus 2 is equal to 0. Now, shall we factorize this? So the factors of this equation are minus 2 and minus 1. So z minus 2 into z minus 1 is equal to 0. Now we can replace z with 2x plus 3y. So 2x plus 3y minus 2 into 2x plus 3y minus 1 is equal to 0, and these two equations are the separate equations. So 2x plus 3y minus 2 is equal to 0, and 2x plus 3y minus 1 is equal to 0 are the separate equations. Thirteenth example, show that the equation 2x square plus 7xy plus 3y square plus 5x plus 5y plus 2 is equal to 0 represent two straight lines and find their separate equations. First, we have to show that the given equation represents two straight lines. So it is the given equation, and now we have to compare it with the general form. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So while comparing these two equations, we get a is equal to 2 and 2h is equal to 7. So h is equal to 7 by 2. B is equal to 3. 2g equal to 5. So G is equal to 5 by 2. 2F is equal to 5. So F is equal to 5 by 2 and C is equal to 2. Okay, now we have found the values of these constants. Now we have to prove that the given equation represents pair of straight lines. So what we have to do? If this determinant form equals to 0, then it means the given equations represents pair of straight lines. So with the given constants, with these constant values, we have to find the determinant value of this one. Okay, so I am substituting the given values and trying to find out the determinant value. So after calculating that, the value is equal to 0. So the determinant, as this determinant form is equal to 0, we can tell that the given equation represents a pair of straight lines. Now what we have to do? We have to find their separate equations also. It's also in the question. So to find the separate equations, we have to consider the first three terms of the given equation. 2x square plus 7xy plus 3y square. Okay. So the first three, 2x square plus 7xy and 3y square. This is the first three terms. So consider that three terms alone and factorize. We have to factorize it. Okay. So 2 into 3, 6. We have to find the factors of this 6. So now in center we are having 7. So the sum of the factors should be 7. So 6 into 1 are the multiples of 6 and their sum is 7. So 2x square plus 6xy plus xy plus 3y square. Okay. So while factorizing, you get x plus 3y into 2x plus y. While factorizing this equation, you get x plus 3y into 2x plus y. After calculating the factors, okay, so the given equation, this is the given equation and I write this as a product of these two factors, as the product of this x plus 3y and 2x plus y. Okay, so with some constant x plus 3y plus L and 2x plus y plus m. Okay, I write the given equation as a product of these two factors by adding some constants alone. So here I add L and here I add m. Okay. So now we have to find the values of these two constants L and m. And then we can substitute in this equation. Okay. So how to find the constants L and m? We have to compare this equation. We have to compare this. Okay. So first compare the coefficient of x. So coefficient of x. How will you get the coefficient of x? Here 5 is the coefficient of x. Right, in this equation 5 is the coefficient of x. What about this equation? Where and all you get the term with x. So if you multiply x and m, there you get an x term. Similarly, if you multiply 2x and L, there also you get a term with x. While multiplying with the other terms, you will not get the term which contains x alone. Okay, so while multiplying this 2, you get 2L. While multiplying this 2, you get 2L. Here, while multiplying this 2, you get 2L. So 2L. Okay. Similarly, while multiplying with x and m, this x and m, you get m. Okay. We are comparing the coefficients of x. So we can write the coefficients alone without the variable x. In the opposite side, in that equation, the coefficient of x is 5. So I am equating 2L and plus m is equal to 5. Okay. Similarly, now we have to find the coefficient of y. How to find the coefficient of y? Similarly, we have to compare these two equations. So, to find the coefficient of y, okay, in this equation 5 is the coefficient of y. Okay, what about the right hand side? To find the coefficient of y, you have to multiply this 3y and m. If you multiply this 3y and m, you will get the coefficient of y. Similarly, while multiplying L and Y, you get the coefficient of Y. Okay. So, the equation is L plus 3M is equal to 5. Here L, Ly, okay. While multiplying L and Y, you get L. While multiplying 3Y and M, you get 3M. Okay. So, L plus 3M is equal to 5. Now, we have to solve these two equations. Simple linear equation solve பண்ணி values கண்டுபிடிப்போம்ல அதே மாதிரி 2L plus equations are 2L plus m is equal to 5 and L plus 3m is equal to 5. Okay, so this is only we have to solve these two equations and find the values of L and M. So, we can multiply, this is equation 1 and equation 2. If we multiply equation 2 by 2, you get equation 2L plus 6M is equal to 10. Okay, now compare these two equations. Okay, while changing the sign, here it is minus and minus and minus. So, 2L cancel. Now, it is minus 5M. M and 6M, it is minus 5M is equal to minus 5. That implies M is equal to 1. Okay, so if I substitute M is equal to 1 in equation 1, so 2L plus 1 is equal to 5. So, 2L equal to 5 minus 1 and it is equal to 4. So, 2L is equal to 4. So, L is equal to 4 by 2, that is equal to 2. So, L is equal to 2 and M is equal to 1. Now, we have found the constants L and M. Now, we can substitute them. M is equal to 1 and L is equal to 2. So, here by solving 1 and 2, we get M is equal to 1 and L is equal to 2. So, the separate equations are x plus 3y plus 2 because L is equal to 2 and 2x plus y plus 1 is equal to 0. Okay, L இருந்த இடத்துல இங்க L இருந்தது, இங்க M இருந்தது. Instead of that, we have substituted 2 and 1 and these are the separate equations. 15th example. Find the angle between the straight lines x square plus 4xy plus y square is equal to 0. So, while comparing with the given equation, you get a is equal to 1 plus and b is equal to 1. Coefficient of x square is a and coefficient of y square is b and coefficient of xy is 2h, right? So, 2h is equal to 4. So, we get h is equal to 2. Now, we have to find the theta angle between the given straight lines. Then, theta is equal to the formula tan inverse of 2 into h square minus ab by a plus b. So, tan inverse of 2 into h square. What is h here? 2. So, 2 square, that is 4 minus a into b. While multiplying a and b, you get 1. So, divided by a plus b, that is 1 plus 1 and it is 2. So, 4 minus 1 you get 3. So, square root of 3. 2 and 2 will get cancelled. So, 4 minus 1 you get square root of 3. So, tan inverse of square root of 3. For which value of tan you have root 3? It is 60, right? So, theta is equal to pi by 3. As I said, here now in 11th standard, we mostly use the angle with this measures only. Okay, so pi is equal to 180. Okay, so pi by 2 is equal to 90 degree. Pi by 3 is equal to 180 divided by 3. So, it is 60 degree. So, instead of 60, here I have written pi by 3. Okay.